Our relationship with the automobile has been a defining feature of modern life. But as we make the transition to electric power, many experts believe that the nature of this relationship is about to undergo a revolution. Without doubt, this presents a challenge, but it also presents the opportunity to redefine the way we travel. No stranger to thinking differently about how we use vehicles is Robin Chase, co-founder of Zipcar, one of the world's leading car share companies, and Venium, a data network company that is helping to support what's known as the Internet of Moving Things. She's worked with institutions and authorities around the world, developing innovative transport strategies.
I think of transportation as our gateway to opportunity. Whether you want to be educated, see friends, have a job, be healthy, go shopping, everything resides upon, can you get there? How much time, how much effort, how much money? It is the glue that makes our entire lives possible. So the idea that there's one type of vehicle or one type of mobility solution that will service all of our needs is craziness. And that was what happened in the last century. When people buy a car, what happens is they think about their largest use case. They think, oh, I need to have it so in August I can take my family on some big trip with everything in back. But in reality, 70% of our trips are us alone in the car. And 50% of our trips are less than 3 miles or 5 kilometers. So the reality is, it's us moving alone by ourselves for the vast majority of our trips. And cars, whether they're electric or not, are vastly oversized for what we're actually doing.
This is the Aptera, soon to be the most aerodynamic production car in history. With a potential range of 1,000 miles from a single charge, it's convinced over 15,000 customers to place an order before a single vehicle has rolled off the production line. But this is not the product of an automotive giant. This is what happens when some engineers from San Diego take an uncompromising approach to efficiency. The Aptera story started over a decade ago, when electrical engineer Steve Fambro, sitting in traffic during his daily commute, became convinced that there had to be a better alternative to existing cars. Something more efficient, and certainly something more sustainable.
So I started building this car just as a hobby. And at some point, the light went on where I thought, if I could get paid to do this, I would do this all day. So I started thinking about, well, what would that look like? What is that? Well, it's a startup car company to sell the most efficient vehicle in the world.
And then Steve met Chris Anthony, an entrepreneur who was building composite wake boats, who not only shared his passion, but was also prepared to think differently.
And it was off to the races. It was really bizarre how quickly it all happened.
Well, you know, when I first met Steve and he explained the math equation for why typical vehicles use so much energy, the first thing that he brought up was a typical Toyota Camry type vehicle will use 60% of its fuel just pushing air out of the way. And it instantly struck a chord with me because I was a hydrodynamicist and I'd done lots of simulation work and worked on how fluids work. And I said, yeah, I get it. That's a problem. And he said, I think that we can build a vehicle that takes that aerodynamic drag almost down to zero. Perfect, sign me up. Let's build that vehicle. And we didn't start with a marketing study or a focus group. We started with the engineering problem of how do you make transportation more efficient? And then we just ticked through the boxes on what would make the most efficient vehicle platform. And what you end up with is something that looks like what I have behind me.
When I first started looking at low drag shapes, I thought, well, let's look at the streamliner hot rods from the 1950s and 60s. You had a lot of veterans who returned after World War II, And we're taking aircraft parts and drop tanks and turning them into hot rods and then taking them to the salt flats and seeing how fast they could go. And for the amount of horsepower and the size that they were, my back of the napkin calculations said that they should have been able to achieve much higher top speeds because of the streamlined shape. What I didn't realize, and I guess maybe what they didn't realize at the time, is that a perfectly symmetrical streamlined shape has very low drag in the free stream, up high in the air. But when you bring it close to the ground, it has a completely different effect. In ground effect, it becomes a much higher drag shape. And so to make a streamlined shape, but that's also low drag and ground effect, it looks different. And as it turns out, lots of creatures, fish, catfish, sharks, etc., that swim in the free stream, when they get down near the surface, they will change their body shape to lower their drag. And the reason they lower their drag is because nature hates inefficiency. Nature doesn't do anything inefficient. It's all about saving energy.
So sharks really taught us a lot about how things work in ground effect. So that's why the Aptera looks a lot like a fish or a shark swimming close to the seafloor with a hump on its back.
Before we went out fundraising, we said we need to have some third-party seal of approval. Who could we get to also examine the shape, maybe put it in their wind tunnel, give us a thumbs up that it is low drag. And so we hired a NASA Langley low-speed wind tunnel. And we had a conference call with them, and you could hear all the scientists on the conference call. They're like, this is the lowest drag road vehicle we've ever seen. Like, what are you guys doing? How does this work? And we said, we hired you to tell us how it works. You're NASA.
What has enabled the team to fine-tune their design in a way that would have been impossible a decade ago are the advances in computational fluid dynamics. This is a computer tool that can accurately analyze complicated aerodynamics and airflows.
We bought a lot of servers. This is after we got our funding, and we ran CFD 24 hours a day for virtually every shape that touches the wind in the vehicle.
The processing power that you can put to these problems now is just immense. We can load a full vehicle model into our simulation deck and run it on a web server and have results in 4 hours now.
Incredibly, the entire Aptera car has less aerodynamic drag than just one side view mirror that you'd find on an average American pickup truck. One aspect of the vehicle's design that often draws attention is the fact that it only has 3 wheels.
We determined that if we got rid of the rear wheel, one, we don't really give up any performance characteristics, but we gain in aerodynamics, we lose some weight from having the structure to hold that extra wheel, and we have less rolling resistance. So you have a certain amount of weight that's deforming the tire constantly on every revolution that you ever drive. So if you can decrease the amount of traction patch on the road, you get better overall efficiency.
Our vehicle can go around the track as comfortably and as securely as any comparable 4-wheel vehicle.
And one thing crucial to its stability is its center of gravity, which is greatly helped by the choice of powertrain.
How we power the vehicle is actually through the wheels. The motors are designed into the wheels. It takes the weight and puts it out at the corner of the vehicle, so you have a better center of gravity, which gives you more torque, so you get better 0 to 60 time acceleration, and it gives you more regen capabilities, so it saves your brakes and gives you better overall performance. Weight is crucially important to our efficiency, so the more we can reduce weight, the better.
And one of the heaviest parts of an electric vehicle is the battery.
Well, batteries are the most expensive part of the electric vehicle. And so if we can fundamentally reduce the number of batteries necessary to go from point A to point B compared to any other electric vehicle, then we're able to offer something that costs less to make and costs less to sell.
The combination of less weight, reduced rolling resistance, and world-leading aerodynamics means you need less energy to power it.
With 100 watt-hours per mile energy usage, you can do things like charge with a regular extension cord from your garage. The same cable that you charge your cell phone with is a cable that you can charge the Aptera with up to 200 miles overnight. Also, you know, if you're on a trip and you go to one of the roadside chargers, you're charging 4 or 5 times faster than any EV around you.
But the Aptera has one more energy-saving trick up its sleeve: its solar-powered charging capability. All the more pertinent given the US Department of Energy's predictions that electricity consumption is set to increase by as much as 38% by 2050.